So hi guys, my name is Sergey and I'm with CARIAD. Today I will be talking about ArchE, which is an architectural framework for the automotive domain. Before I start, you probably see that there are several names on the slides, which are basically my colleagues who helped me to do the slides. But apart from that, there are many more people involved in this project from CARIAD, but also external partners. Without them, we wouldn't come that far. So I just wanted to mention that before I start. Having said that, I would start with a short introduction, since I guess not everyone of you is involved in all those craziness which we have in automotive. So I will give you some introduction in the problem at hand. So you may or may not have heard the term software-defined vehicles. And what does it actually mean? It means that software becomes more and more important for car industry. And the features which different car makers use to differentiate themselves against other competitors used to be maybe the size of engine or fancy design. And I think this is so important, but software becomes more and more important in order to differentiate yourself from the competitors. One reason for that is that the new generation of customers, they grew up with smartphones and computers, so they want their car to be smart. On the other hand, it also opens a lot of opportunities for the car makers, new business opportunities, like you can do updates over the air, so you don't need to go to the mechanic if something is not completely right. So a bug fix can basically be made on the fly. You can sell new features, so software features, over basically an app store to your customers. Even after they bought the car, you can still make more money. And also you can have like some subscription plans where you basically sell features temporarily. So everything we know from cell phones, that would also go into cars. You can upgrade deployed functions. You can learn from current operations. So one example for that would be the shadowing mode, which I think was introduced from Tesla, where you basically have autonomy in the background and you compare the autonomy decision with the decision of the driver and kind of learn from that. And overall, software helps to improve the user experience in cars. And in order to build those software-defined vehicles, which I would say are basically software systems on wheels, you need to incorporate a more software-driven and software-centric mindset when you develop your car, and not only for people who develop the software, but also for other development roles who are involved in development of the vehicles. And in order to achieve that, you need the right process, method, and tools. I will basically talk mostly about tools, but yeah, those are all important. And the question is, how does it look currently? What is the state of practice in automotive industry? The state of practice is that you have a lot of different commercial off-the-shelf tools, which for each domain you have multiple tools potentially. So you have a tool for hardware, software, potentially several tools for architecture, and so on and so forth. And what is the problem with that? The problem with that is, and I think that's nothing new to you, that if you have multiple tools and build tool chains which are quite loosely coupled over import-export mechanisms, you often have duplicated information because they are overlapping information in different tools, and you change it in one tool, forget to change it in the other, which causes inconsistencies. You have content which is completely disconnected from each other. So a guy who is responsible for the architecture changes something which actually causes some problems with the safety argumentation, but he forgets to tell the safety people about that. Then the problem about the commercial off-the-shelf tools itself, they are quite generic because they created to fit as many customers as possible. Most of them are even not designed to fit the automotive domain, but generally they try to be as generic as possible, which is not good for us because it doesn't really fit completely our needs and it doesn't incorporate our IP. Some of the tools you can adapt but the adaptation are often minor and it's not enough for us. The other thing is semantics between tools. So if you build tool chains and you exchange information, one thing can mean one thing in one tool, and the same thing means something else in a different tool, which might cause a problem. On the other hand, also the modeling languages itself, like SysML, UML, which are very popular in our domain, they have also semantical ambiguities. And this potentially might cause problems, since then different divisions have basically speak different SysML dialects and potentially don't understand each other. And another thing which is quite big for us, that we have little influence as car makers on the roadmap of different tool vendors. I mean, we can ask them nicely, give them a bunch of money, and potentially they will say, okay, we do that. But how long does it take? It might take months, or maybe even a year. And that's not the pace we need to go right now if we want to catch up with our competitors. So what we decided, that we have to own our tools, and therefore we designed yet another domain-specific language for systems engineering. I say yet another because I'm in this area for almost over 10 years now, and that's not the first project I'm working on. So, but nevertheless, every time you come to the point where you say, okay, that's what's available in the market, it's not enough, and it doesn't really completely fit what we actually need. And therefore, we decided to design ArchE. Obviously, so we use the MPS technology, obviously, because otherwise I wouldn't be speaking here. We strongly incorporate the DevOps mindset for the tool and content development. I will talk about that a bit later. We try to capture existing standards because that helps the new users to get accustomed to our tool. So for instance, we use the SysML v2 standard. So we basically let us self-inspire when we design our domain-specific languages by a SysML v2 standard, because we think that our customers are more familiar with this kind of language, and that makes them easier to switch to our tool. And since it's an in-house development, more or less, we develop it hand in hand with our users, so they can really influence how the tool will look like. We have strict semantics. We make heavy use of generators because, I mean, just models without doing anything with them is a bit waste of models, I would say. We have editors, and that's what ArchE is about. I haven't brought, so I will not do a live demo now. I mean, I can do that in a coffee break if anyone wants. But I will just show you a couple of pictures how this tool looks like. So on the left and on the top right, you see the 3 different views of the same thing. And that's basically the point, because we have very different stakeholders and they have very different needs in terms of how they want to look at the model. A lot of them are very graphical users, so when we show them their textual view, they are not really familiar with that, and it's a steep learning curve for them. So we have a lot of graphical editors as well. On the bottom right, you also see maybe another example where you have 2 different views on a state machine. One of them is, again, graphical. The other one is inspired by the SysML v2 textual format. And that's the way how we're progressing. So we basically try to catch as many stakeholders as possible by offering them different ways to interact with our tool. So again, I wanted to say something about the development mindset. So since the development in the automotive industry becomes more and more software-centric, so we also try to move according to the product development itself. So basically, how do you develop the car and the software for the car goes in the DevOps loops, where you basically plan something, code, deploy, and then iterate over and over again. And it doesn't really go only for the code, but also for the architecture. And we, as a tool development team, we move along together with the product developers. So they basically do one iteration, then they mirror us back. What are the problems? What would they need in the tool in order to support them and to move faster in the product development? And then we try to make them happy. And so basically, there's a slight mindset shift away from start of production to more agile way of doing things. And the same goes for the tool development. We go away from frozen commercial off-the-shelf tools where we have the version 20.3 dot something, which we have for the next 5 years. But we have live tooling, which changes together with the requirements of the users. Now we'll lose a couple of words about how the project and the users and our models look like. I had to lead a couple of numbers because otherwise I wouldn't have made it through clearing, but I can try to give you approximate numbers. So we have around 5 to 10 tech leads, so to speak, who define the roadmap of the tool and basically decide in which direction we continue. Then we have like 20 to 30 full-time language engineers who develop features basically and languages for our users. Then we have a set of people who deal with the infrastructure because we have a lot of users and they produce a lot of content, so the infrastructure has to be there in order to accommodate that. And then we have the advanced users. Basically, we call them the facilitators or power users. Those are the people who work closely with us together and give us feedback in which direction we should go. And furthermore, those are the people who are quite convinced by the tool and they also convince their colleagues. And that's the way how we try to convince more and more people, because obviously not everyone wants to have a new tool. When it comes to releases, well, we release so we used to release every 2 weeks. I think now we changed to every 4 weeks, and then a couple of hotfixes in between. You know how it goes. We follow the Git workflow, which is probably not surprising to any of you. And furthermore, we as a project use heavily and also try to contribute to open source projects, which you see on the right. I think I don't have to explain those projects to you, since I think most of the people know better about these projects than I do. When we look at our users, so who are our users? They're very different. So we have architects, we have safety engineers, we have software engineers, and so on and so forth. And well, my manager made me say very good acceptance of ArchE among different users. I would say good acceptance. It depends, I guess. So with whom you're talking, some people really love it, some people hate new things and need to be convinced. We have quite a large number of committers already on our main user repo, our main branch on the user repo. I think it's like around 50 plus committers who commit regularly. We have currently around 100 something plus users who use ArchE. Not everyone uses it on a daily basis. Some of them just log in maybe once a month or so, but nevertheless. And the target would be like around 200, 300, 400 users when we fully roll it out in the VW group. So yeah, and those people will produce a lot of content. And for all those people who, most of them are quite new to the MPS technology, we also established a training program where we basically help them onboarding. Also remember yesterday's discussion about domain experts in Git. My personal opinion, but maybe it's just my opinion, is that people who work in a technical field, they have been going through very hard things during their studies, so it for them shouldn't be a problem, but some people might disagree. But I mean, apart from Git, obviously we have to teach them how to use MPS, the technology, because like all those editors are quite new to people, and also just to tell them we have also specialized trainings for people who need to do only one specific thing in our tool. When we look at the models, so we have managed repositories, so managed basically by the ArchE development team. And we try to have a mono-repo approach. I say we try because it doesn't work out for everything. I mean, some models basically need to know basis, so they need to be hidden somewhere, so they cannot be in the same repo as everything else. And then some models are so huge that they actually cause performance problems. So we move them to other repositories, and then load them as dependencies in order to fix the performance issues. We use help root persistency, and also we try to enforce the equality between model names and folder names solutions, because that makes the diffing for our users easier, because otherwise they get confused. And since, as I told you, those people are mostly very inexperienced in terms of MPS and also in Git. Also nothing very fancy for you, but for our users. So we have one main branch, basically, which is logged. You have to do pull requests. Those pull requests will be reviewed by domain experts, which are from your team, but also from people with a bit more MPS knowledge. We call them code readers, because, as I said, those people are quite inexperienced, and they tend to sometimes commit and push things which are not really necessary, and sometimes you need to look over it. Then the other thing is that we have different parts of the model or of the repo have governance from other different groups of people. So, for instance, a guy or a person from infotainment shouldn't be able to change something in the battery management part of the model without the battery management team approving that. And we use the code owner from GitHub, this concept of code owners, in order to enforce that technologically. When it comes to the size of the repository, so we have currently more than 500,000 nodes in our main repo, which translates to roughly 500 models and 100 solutions. Each week, let's say on a good week, we have roughly 30-ish merges into main. So as you can imagine, the content, it gets more and more every day. And as I told you that we release quite often, so release every 2 to 4 weeks, things change, and therefore models need to be migrated. And the way how we handle that is that the main branch in the user repository needs to be always basically on the current version of our tool. But the feature branches can derive. So if you have a feature branch and you want to work on a previous version, you don't want to migrate to a new version yet, because you just don't want to deal with that right now because you have other problems with your project. You can keep it with the older version, but when you want to merge into main, then you would need to basically migrate your things. And the way we do it, we basically encode the ArchE the ArchE version, which is like for each branch we encode the ArchE version using the Gradle dependency logs. So then when you get the branch, then you would know which ArchE to use. And obviously stuff gets changed, stuff gets deprecated, things are deleted, but we try to be backward compatible like for around half a year, or I mean, that's not a precise number, but we try not to make anyone unhappy with our changes. So maybe this is the part of presentation which is more interesting to you guys. What have we learned looking at the size of the project and the amount of people we're dealing with? So one finding which I think we had recently actually, how they called invisible nodes. And for instance, for all the diagrams, a lot of those diagrams store layout information in the model. And this is not, you don't see it actually that easy. And at some point we realized, our merges and our diffing becomes very slow. And then at some point we found out that this is the problem. So now we actually only store the layout information on demand. And we, I think, even kind of hidden this option of storing layout information, so people only if they really want it can do that, because we don't want to pollute the model with information which actually doesn't really bring so much value. Then obviously, when the models become big enough, the generators speed becomes a problem. I mean, in one of the recent talks, this was also a topic. So one thing what we noticed is, I mean, obviously not every model not every model is suited for generation, but even if it's not used for generation, still the generator starts up and does something for a small amount of time. But if you have enough content, it just builds up over time and then also slows you down. So what we do now is that we know that if a certain model is currently not used for generation, we explicitly set it to do not generate, and that helps us a bit with the performance. And on the other hand, also the input models to the generators, if they're very large, then you also could run into problems. And what helps is basically to kind of try to prune out the information you don't need and only give the stuff to the generator which is really needed in order to improve performance of the generators. Then we have also the problem that our models sometimes get too big because we import them from other tools, and then we have a bunch of data. And we had at some point the problem that it really slowed down our tool when huge models were present in the repository. So what we try to do now is that we kind of lazy load the huge models. So if you don't need them, they are not loaded into memory. And also we move certain parts which are very huge into different repositories and then basically load them as dependencies in order also to battle this performance issues. What else have we learned? So obviously, as I said, again, our users are quite inexperienced in this technology, so we need to try to help them. So one way of doing that is using linters, basically that automatically check certain things, like for instance that the solution is in the right format and so on and so forth. Another thing is that a lot of our users are used to work in tools which are more or less drawing tools. So you can just draw something and then just experiment and then show you to your colleague. And that doesn't really work out sometimes with a formal model, because then you have a check on the CI and it breaks, and then people are unhappy because they just wanted to do something very quickly. And for this purpose, we would need something like whitelisting. We use whitelisting, so basically some models are whitelisted that it's okay for them to be slightly broken. We also noticed that sometimes when we merge separate nodes into main, that some not migrated nodes are merged into main. So this problem I haven't experienced myself, but that happens sometimes. And we also need to have reproducible builds for different reasons. And for this, we basically use Gradle logs, so Gradle dependency logs, to log dependencies, models, and the ArchE version in order to be able to reproduce every build. What do our users say about our tool? Well, it's not a surprise to you, because I think that's the feedback you always get with people who are new to MPS. The textual-based modeling is just very difficult, regardless whether you're used to graphical modeling, because or if you're actually used to the real textual modeling where you write text. The way how MPS does it is, it's new to other people, and it's a steep learning curve for them. But offering different views on your model and trying to incorporate different feedback and wishes of users does help there. The other thing is, the formal models and model checks are awesome, because you find errors, and that people also love a lot. But other people, as I said, actually just want to sketch. So they just want to draw something, just do something very quickly. And they are confused if MPS starts bleeding and everything is red, and they just get scared that they broke something. So this is something which people are not completely used to. This is a slide which I was asked to include. So obviously there's a much better way of giving feature requests or asking for new features, and I'm pretty sure that we will go the proper way as well. But I just wanted to talk about 3 things which I found interesting. One of them is the model check. since, I mean, all of us have multi-core machines and they're quite powerful, why not make use of it and then parallelize basically the model checker? I think that would be something which would help us. Another thing, and that's, I think, is super easy to fix with when you diff in MPS, you cannot filter for file extensions. And if you're new to MPS and you don't know what all those extensions are, it's quite confusing. And so if you have like some custom filters for that, that would potentially help some users who are new to Git. And another thing, and I think that was already a topic of several talks, like if you have very large root nodes, I mean, I get it, don't have them, just divide the root nodes. But sometimes in certain moments, you just have it. And one way to deal with that, and that would actually really help, is to have a basically incremental loading of large root nodes. Or some lazy loading or something like that. Yeah. Actually, I think I was talking much quicker than I expected. So that would be my last slide, which basically summarizes the key takeaways. So there are new challenges in the automotive industry, and it becomes much more software-centric. So we need to adapt in order to move fast, and we have to adapt to a more software-centric approach. For that, we need the corresponding tooling, which is flexible enough in order to catch all the different user groups we are having who are coming from very different backgrounds. Yeah, and that's what we're trying to achieve with our project. Thank you.
What was the key selling point to your management to go this make your own tools versus using all the crazy third-party tools?
I guess the fact that I mean, if you read the press, then you see that it feels like the German car makers falling behind in terms of software development, and I mean, I would not disagree. And that we need to find new ways of speeding up things in order to catch up.
Yeah, thanks for the nice talk. There is a plugin for multi-threaded model checking, which is open source, and I developed and reuse. So as you said, you are willing to contribute to open source, so we would be really happy if you could use it, provide some feedback, and maybe improve it. We already have some ideas in mind to even improve this plugin. So if you want to check it out, it's on GitHub. It's called Concurrent Model Checker.
Cool, thank you.
Just as an idea.
I just want to notice that we also joined to feature request, the first and the third one you showed on the slide. And could you show it again?
Yes.
Okay, multi-thread model checking. Is it also support the GPU or not, this additional feature? I guess not. We are free to extend, okay. And the other question, actually the real one, maybe I didn't get the architecture point of view. You provide also the visualization, because you mentioned it's text-based, and I saw on one slide there was the state machine diagram.
Yes.
And also, as we know, for the architecture, I mean solution architecture, we have UML or also the Archimate standards and so on. So what do you support here as a visualization?
I mean, that's from the tool. That's actually what we support. I was basically, actually my point was that we started with the textual one, but this is something which our users kind of struggle with, and then we came up with more different representations for the same thing.
Okay, so you end up in a text representation of the model, right?
So both textual and graphical. So you can switch. You can actually see it on top where you can basically toggle between graphical and textual.
Okay, and this is the standard way of visual components, or it's something like a custom?
So I think this is based on MPS extension. If I'm so this like I think other people know better than me.
SysML, okay. Okay, so there are no standard like UML. It's just the SysML. Okay, I get it.
So also it's not completely that we completely reuse SysML. We basically let ourselves inspire by SysML where it fits.
Okay.
So just in order to be more familiar to our users.
Because you mentioned.
I mean, component-based architecture is a standard for this type of. But I mean, the textual representation, so what you see for the state automaton, this is based on the SysML v2 standard, which is not released yet, but we like the fact that in SysML v2 you have the textual and the graphical representation, because in the SysML, the normal SysML, you only had the graphical one. And in the second version, you have the textual and graphical, which kind of fits also the design, how we think it should be. And that's why we try to adopt where it fits.
And why don't you use UML?
I mean, apart from the fact that UML is not very strict in terms of semantics, it's not really heavily used in our domain. But I mean,
Okay.
SysML and UML, they are quite similar in terms of what kind of diagrams you can do. But SysML is more for the embedded systems world, I would say, is used there. And that's why we inspire ourselves more by SysML, because our customers already know SysML anyway.
Okay, that's the reason. Thank you.
Is it just an inspiration from SysML v2, or is there any compatibility between the standard and ArchE?
I would say it's rather inspiration, but I think Daniel wants to say something.
So SysML v2 is in progress, right? The standard is not released. In fact, we implement in an MPS style a base language, which is SysML v2 a subset, and then extend with our higher level abstractions.
Any more questions? Thank you.
Thank you.